Hello students. Today we are continuing with the alloys of metals. Previously we had taken up brass as one of the alloy. If you remember it, brass, as we discussed, is an alloy of copper and zinc. Today we'll continue with the bronze and aluminum alloys. Uh, we studied what is an alloy also in the previous class. I'll just share a presentation with you and we'll continue with bronze as one of the alloy of copper. So students, as I said, we are discussing alloys. What is an alloy? Alloy is it is a mixture of metals. It is a combination of the metals to get the better properties out of it. So every metal will have its limitation. To overcome those, we are forming the alloys. So we started with the brass as one of the bright alloy, which is used uh, in many purposes. It has many industrial applications. It has applications in the mechanical industry, automobile industry, in the mainly in the hardwares, and it has also has good applications in the building industry. Now we are moving to the bronze. So what is the difference between brass and bronze? As we discussed, brass is an alloy of copper and zinc, whereas bronze is an alloy of copper and tin. The difference in the appearance is brass is more brighter than the bronze. You can see here in the picture brass and bronze. Bronze looks little bit duller than brass. Both of them are alloys of copper, which have better properties than copper in the appearance in many purposes. So we'll continue with the bronze in the next slide. So previously in the previous presentation, we had just skipped what are the types of brass. As I said, we are studying the alloys. Brass is one of the alloy of copper. We studied that it is an alloy of copper and zinc. So according to our requirement, we change the composition and we have a different types of brass. So we have the red brass here. The first one is red brass, which consists of 85% copper and 15% of zinc. This performs better than copper in anti-corrosive properties. So it is quite hard and strong also. Uh, and next is you have the white brass. As name itself indicates, it consists of less copper. That it consists of only 10% of copper, and it has a 90% of zinc. So it is more of zinc than copper. Since due to the addition of copper, due to addition of copper, zinc properties are changed. It becomes more harder. It is used for many decorative items. So next is we are talking of yellow brass, which consists of 65% of copper and 35% of zinc. It is also called as standard brass. It is used in many plumbing applications. It is also used for uh, screws, nuts, bolts. So many purposes it is used. Yellow brass. It is called as standard brass. So next is low brass. It is moderately stronger, which consists of 80% copper and 20% of zinc. So it is used in the musical instruments and decorative items. Next comes your naval brass. As name itself indicates, it has applications in marine engineering. In the pump rods, it is used. So its composition is it consists of 59% of copper, 40% of zinc, and you have 1% of tin. What happens in the brass, as I said, it is an alloy of copper and zinc. We do not have tin in brass, but whereas in naval brass, 1% of tin is also added. It has applications in marine engineering. So it performs well in water. So you have next variety of brass is cartridge brass, which consists of 70% of copper and 30% of zinc. It is used for the cartridges. So these are the various types of brass. Due to the variation in the composition, we can get the different types of brass according to our requirement. Next, we are moving to the bronze. As I said, bronze is an alloy of copper and tin, whereas brass is an alloy of copper and zinc. So it is an alloy of copper and tin. The percentage of tin is 12%, remaining is copper. So it does not have only copper and tin. Even the brass do not have only copper and zinc. It has many other elements also added there. So here also you have manganese, aluminium, nickel, phosphorus, silicon, arsenic, and zinc, which are added to copper and tin to get the bronze. So you can see the appearance of bronze here, which is used for the medals, and it is also used for decorative articles. Next, we'll move to the important properties of the bronze. As I said, brass and bronze are much similar. Only thing is with its composition and appearance. So even bronze is highly ductile. Highly ductile is it can be drawn into wire form. And next, it exhibits low friction against other metals. So because of this property, it is used for screws, nuts, and other accessories in the mechanical and automobile industry. Next property of bronze is it is brittle. It is brittle, but compared to cast iron, it is less brittle. Brittle, but less than cast iron. And upon exposure to air, it oxidizes. So we studied about surface oxidation in copper. Copper, as I said, it forms a bluish green coating when exposed to the air or atmosphere. Here also bronze also oxidizes, but compared to copper, it is lesser. These are some of the properties of the bronze. So we'll just discuss what are the types of bronze. As I said, according to our requirement, what we are doing is we are changing the composition and forming the alloys. In types of bronze, we have four types of bronze, that is bell metal, gun metal, manganese bronze, and phosphor bronze. When I say bell metal, the name itself indicates it is maximum its utilization is for making the bells. So its composition is 82% of copper and 18% of tin. So you might have seen the bells in your puja rooms, in bell in the temples, which are all made of bronze. So it has a resonance properties. It has a good acoustical properties. So it is used in the bells. It is quite hard and strong also. So next is we are moving to gunmetal. We are discussing types of bronze. First one is bell metal. Second one is gunmetal. Gunmetal consists of 88% of copper, 10% of tin, and 2% of zinc. So you can see here, as I said, bronze is an alloy of copper and tin. We don't have zinc there. So here in the gunmetal, 2% of zinc is also added. So it is also used for making the guns. It is used for the other hardwares, accessories in the mechanical and automobile industry for screws, nuts, bushings, etc. Next is manganese bronze. Third variety of bronze is manganese bronze. The name itself indicates here. Again, you have the percent of manganese here. So the main constituent is copper again, 56 to 60% of copper. You have up to 1% of manganese. You have up to 1% of aluminum, and the remaining you have the zinc. So manganese bronze performs very well in water. It has anti-corrosive properties. So it is used in the subaqueous constructions and wherever it has to resist water. Next is phosphor bronze. Again, which consists of 89% of copper, 10% of tin, 1% of phosphorus. Again, this also has the anti-corrosive properties. It is also used for submarine or subaqueous structures, and it is also used for springs, bearings, etc. So we have four types of bronze: bell metal, gun metal, manganese bronze, and phosphor bronze, with a change in the composition of copper and tin. Along with that, we have many other elements. In every metals and in every alloy of metals, what we are studying is we are studying introduction of that metal, the composition of that metal. We are focusing on the properties of the metal. Then we are focusing on its applications. Here also we studied its properties. We studied the types, and now we are studying what are the uses of bronze. So we studied about bell metal, gun metal, phosphor bronze, manganese bronze. So every type of alloy has its own applications. So the same way here we are just listing down its uses or applications. As I said, it is used in the making of the bells. Since it has a less friction for other metals, it is used for bearings, bolts, nuts, etc. Since it has anti-corrosive properties, it performs better than copper in water. It is used for ship fittings, shafts, axle. It is also used since it is very easy to work with. It is flexible. It is used for springs, gears, bearings. It is also used in the telescopes. For us, the more important about any metal is what are its architectural applications. So the pictures here show you what are its applications. So as I said, brass and bronze are used more as a decorative uh, for decoration in the interiors mainly. So since they have a good appearance and they have anti-corrosive properties and they are malleable and ductile, so they are used in the hardwares of doors, windows, wardrobes, cupboards, etc. What do you mean by hardwares is for the handles, for the knobs, even for the bolts, for the hinges. They are used, even bronze is used for the hardware of door entrances. And since it is a decorative, as I said, it is used for a decorative purpose. It is used in the fountains, cladding, column cladding, in the architectural details like medallion, paneling, etc. Medallion is these are the things which are put on the walls. Even the exteriors of the buildings, you can see some of the structures which are made of bronze. So in architecture, they are also used for the hardware. They are also used for the decorative purpose. They are used for the cladding, for the fountains, medallions, panels, etc. So next we'll move on to the alloys of the aluminum. So we have studied aluminum already. What are the alloys of aluminum? So as I said, according to the requirement in the industry, the alloys are formed. Aluminum will be having its own limitations. By adding some other elements, we can overcome the limitation of any metal, and it will perform better than the independent metal. Here we have four types of alloys of aluminum: aldural, aluminum bronze, duralumin, and Y alloy. We'll be dealing with this independently in the next slide. The first alloy of aluminum what we are studying is aldural. Aldural, aldural is also called as alclad. So what is it? It is a duralumin with a thin coating of aluminum. Duralumin is also one of the alloy of aluminum. When it is has a thin coating of aluminum over it, it is called as alclad or aldural. And the coating is about 5% of the thickness of the core. You have the core which is made of duralumin, then over that you have the coating of aluminum. The coating is around 5% of the core. And what is its properties? It prevents corrosion due to salt water. Next, we'll deal with the aluminum bronze. As I said, four types of alloys. First one is aldural or alkali. Second one is aluminum bronze. Aluminum bronze, when you say the bronze, when you say it consists of copper. So here you have less of aluminum, that is 10 to 22% of aluminum you have. Copper is 78 to 90%. So it is quite harder. The addition of copper makes it harder. So it has a properties yellowish brown. It is strong, hard, light, elastic, and malleable. And it is used in the die casting. Die casting is nothing but casting of metals in the molten form, in the molds. So metals in the molten form are cast using the molds, that is called as die casting. It is also used in the pump rods. So this is the second alloy. Next, we are just discussing about duralumin. Duralumin is an important alloy of aluminum, which has a wide applications in the aeroplanes, in the aerospace parts. It is duralumin is used. Its composition is, it has aluminum up to 94%. It has copper 4%, magnesium it has 0.5%, manganese 0.5%. It also has silicon 0.5%, iron 0.5%. It is strong and it has a high electrical conductance. We have studied about aluminum, its properties, its high electrical conduction, good thermal conductivity. So it is used in the aircrafts. It is also used in the automobile industries, electrical cables, and surgical instruments. So duralumin is important alloy of aluminum. The last alloy of aluminum is Y alloy. It is called as Y alloy. It consists of aluminum 92.5%, copper 4%, nickel 2%, magnesium 1.5%. It is a good conductor of heat and it has high strength. And it has more application in the automobile and mechanical industry. It is used in the pistons of engines. It is used in the cylinder heads. It is used in the gearbox. It is also used in the propeller blades. So by this, we are ending with the alloys of aluminum also. So this chapter is ferrous and non-ferrous metals. We dealt with the ferrous metals. We dealt with the non-ferrous metals. Then we have started with the alloys. As I said, alloys with a change in the composition, we are getting the desired property of out of any particular metal. So first you studied about copper alloys. There are two types of copper alloys, that is brass, and two important alloys of copper are brass and bronze. Then we just have moved to the aluminum alloys, in which you have alclad, you have duralumin, you have aluminum bronze, you have Y alloy. So we are studying about the alloys. By this, we are ending with the presentation about alloys. So we have finished with the alloys of aluminum, and the last part was left out, that is your steel alloys, which I'll be sending you the notes. Steel, with the addition of many other elements, we get a different alloys of steel which are used in the industries. So you have molybdenum, you have vanadium, you have the copper, you have nickel, you have chromium, which are added to the steel to get a different alloys of steel. That I don't think you need the explanation, only the composition and its applications are required, which I'll send you the notes. So by this, we are ending with this chapter, that is ferrous and non-ferrous metals. Next, we'll start with glass and plastic, next chapter. So I'll end the meeting.